So in these problems, we're still going to work with the law of sines. So remember we said the law of sines, if you have any old triangle, A, B, C, with little a, little b, little c, the law of sines says that the sine of A over little a is equal to the sine of B over little b, which is equal to the sine of C over little c. And the law of sines lets us be able to solve triangles. So, for example, solve the triangles. And we're going to round to the nearest tenth. So our first one here, we're going to have little c equals 40, little b equals 63, and capital C equals 28 degrees. So if we think about drawing a triangle, and I label these A, B, C, so little c 28 degrees, big C 28 degrees, little c 40, little b here 63. So the first thing that if we look, we have the pair for C and here, and I have the side for big B, so I have little b, so I can find big B. So we're going to look at the sine of big B over 63 is going to be equal to the sine of 28 degrees over 40. So the sine of big B is going to be multiply up by 63. So 63 sine 28 degrees over 40. And now I want to figure out what B is. So to figure out B, I need to take the inverse sine of this. So B is going to be equal to the inverse sine of 63 sine 28 degrees all over 40. And so if I do that, that actually turns out to be 47.7 degrees. Now, if you remember about the unit circle, the sine is positive in the first quadrant, but it's also positive in the second quadrant. But the inverse sine only gives us angles in the first quadrant. So to be able to find, there's always going to be an angle in the first quadrant as well as an angle in the second quadrant. So the other angle that it possibly could be is it could be 180 degrees minus the 47.7 degrees or 132.3 degrees. So basically what we have is when you use the law of sines to find an angle, you always get two cases. So in this case, the first case, so case 1 is going to be that big B is equal to 47.7 degrees. So if big B, so if I drew a picture here for case 1, it's going to be, I have the 28 degrees, and then we're saying B is 47.7, and then I know this side is 40, this was B, A, C, and this side was 60, and this side was 63. So I can use these angles now to find A. So A is going to be 180 degrees minus 47.7 degrees minus 28 degrees. So in this case, A is going to be 104.3 degrees. And now I can use the law of sines to say that the sine of 104.3 degrees, and in this case I have to use that value that we found that is estimated, but it's okay, over A is equal to the sine of 28 degrees over 40. So let me slide this up here a little bit. A sine 28 degrees is going to be equal to 40 sine 104.3 degrees. So we're going to divide both sides by the sine of 28 degrees, sine 28 degrees, and in this case, A is going to be approximately 82.6. So that's the first case. So this problem is actually going to have two answers here when we go to write it down in a couple minutes. So one answer is going to be what I just found over here. For the second answer, we have to look at case 2. And so case 2 is going to be that big B is equal to 132.3 degrees. So again, my triangle here, so we have A, B, C. So again, I have 28 degrees. Now I'm saying that B is 132.3 degrees. This side's still 63. This side is still 40. So same as before, A is going to be 180 degrees minus 132.3 degrees minus 28 degrees. So in this case, A turns out to be 19.7 degrees. And then we should do what we did before. So the sine of 19.7 degrees over little a is going to be equal to the sine of 28 degrees over 40. So cross multiply, a sine 28 degrees equals 40 sine 19.7 degrees. Divide both sides by the sine of 28 degrees. All that. And so A, if you do that, is going to turn out to be approximately 28.7. So there are two solutions here, right? One solution has capital B as 47.7, capital A as 104.3, and little a as 82.6. And the other solution has capital B as 132.3, capital A is 19.7, and little a is 28.7. So let's try another one, because it's not the case that all of your triangles always that you always get two answers, even though you look at two cases. So B equals 5, C equals 12, capital C equals 73 degrees. So again, here's my random triangle. A, B, C. So we know C is 73 degrees, little c is 12, little b is 5. So again, if I use the law of sines, I know the sine of 73 degrees over 12 has to be equal to the sine of big B over 5. So if I cross multiply, 12 sine big B equals 5 sine 73 degrees. Divide both sides by 12. So the sine of B is equal to 5 sine 73 degrees over 12. Take the inverse sine. So B is going to be the inverse sine of 5 sine 73 degrees over 12. And so this turns out to be approximately 23.5 degrees. So that's the first one. Or it could end up being in the second quadrant, so it'd be 180 degrees minus the 23.5 degrees, which would be 156.5 degrees. And now I'm going to look at my two cases. So case 1, we're going to have, so we have to find A first. So A is going to be 180 degrees. So again, this is what my picture looks like, right? A, B, C. We know this is 5, this is 12, this is 73 degrees. And we're going to do that first case where B is 23.5 degrees. So to find A, we're going to take 180 minus 23.5 degrees minus 73 degrees. And if we do that, we end up with A being 83.5 degrees. And then we have to find little a. So the sine of 83.5 degrees over little a is going to be the sine of 73 degrees over 12. So cross multiply. 12 sine 83.5 degrees equals a sine 73 degrees. Divide both sides by the sine of 73 degrees. And we end up with A as being approximately equal to 12.5. So I solved the triangle one way, and so now I have to look at case 2. And so case 2, A, so same thing, A is this time going to be 180 degrees minus, this time B is 156.5 degrees, minus 73 degrees. And if you do that, you would end up, A would need to be a negative 49.5 degrees. Now, we can't have a negative angle in a triangle, so in this case, there's no solution because there's no way for us to have that negative angle. So we'll do one more. So C, B equals 6, C equals 12, capital B equals 38 degrees. So, again, here's my triangle, A, B, C. So little b is 6, little c is 12, capital B is 38 degrees. So the first thing I want to do is try to find capital C. So the sine of capital C over little c is going to be equal to the sine of 38 degrees over 6. So, and we know little c, right? I should have put what that was. So sine of capital C over 12. So if I multiply up by 12, I end up with sine of C is equal to 12 sine of 38 degrees over 6. Now, in the last problems, we then take the inverse sine, right? So C would be equal to the inverse sine of 12 sine 38 degrees all over 6. If you try to punch that into your calculator will yell at you. It will say you can't do it. And the reason why is because if you look at the stuff inside here, the stuff inside here is actually roughly 1.23. And so it's a number bigger than 1, and the sign only goes between 1 and negative 1. So you cannot take the inverse sine of this, which means that this triangle cannot exist. So there is no triangle or no solution. So there is no way to actually get this triangle made. So you cannot have a triangle that is, starting in with these values. There's just no physical way to actually make that triangle.